And today we're going to take a look at section 1.4, which is, I'm going to say special triangles and special angles. And they're special because they're all the angles in a unit circle. So for section 1.4, you should have handy with you, I'm going to go into this lecture, the formula sheet section. And I'm going to pull up the unit circle function values chart. All right, we had taken a look at this chart before, and what it gives you are the 6 trig functions for every angle in the unit circle. So this is basically the only thing you're going to need for section 1.4. I'm also going to go into the lecture notes section, and I'm going to bring up in the lecture notes section, section 8.5, this set of notes. And we'll just take a look at the first couple of slides, and this is called circular functions, and it says the trigonometric functions when defined for all real values are referred to as circular functions. To define the circular functions for any real number s, use the unit circle. The unit circle is a circle that has a radius of 1. And we talked about clockwise angles are angles that are rotated clockwise, and they are negative angles. Angles that are rotated counterclockwise, and when I say rotated, it's simply how that terminal side of the angle moves. If that is rotated counterclockwise, then we have what are called positive angles. I'm also going to pull up the unit circle. And again, that unit circle is on the all exam formula sheet, and then it's also a separate document unto itself. So that unit circle function of values and the unit circle, they go hand in hand. On the unit circle, however, we kind of discussed that the x values are cosine values and the y values are sine values. And this unit circle gives you only the sine and the cosine values. Whereas the unit circle function value sheet, it gives you all 6 trig functions. All right, so just taking a look at this unit circle function value sheet, and if we take a look at some of the homework problems. This is problem number 1. It says find the exact value of the expression, the cotangent of 240. So in order to find the cotangent of 240, I'm going to pull up the unit circle function value sheet. I'm going to find 240 degrees, which is 4 pi over 3 radians, and its cotangent should be positive square root of 3 over 3. All right, so here we get square root of 3 over 3. That is basically there all to it for section 1.4. Simply finding because all of these angles are in the unit circle. Right? So every last one of these values are in the unit circle, except there are some problems that ask for the reference angles. So let's take a look at a reference angle problem. I guess number 7. It says use reference angles to evaluate. Well, I guess even though it says use a reference angle, you could actually just use the cosecant of 315 degrees. So I can find 315 degrees. I'm looking for the cosecant. I believe that's going to be negative square root of 2. So even though it asks for you use a reference angle, since we have the unit circle functions value sheet, there's no need to use a reference circle. You can basically pull the value from that table. The things that are not actually on the table per se is one like problem number 10. Problem 11, and I believe problem 17. We'll take a look at all of these. So let's take a look at problem number 11. It says find the exact value of the expression without using the calculator. The cosine of 135 degrees plus the secant of 45 degrees. I'm going to copy this over so I can write on it. All right, I'll just copy all of that over. All right, so we're actually to find the cosine of 135 plus the secant of 145. So I'm simply going to pull these two values from the unit circle function of values, and I'm basically going to add them together. Okay, and what's going on with Okay, just give me 1 second to get it. All right, so first we're going to find the cosine of 15 degrees. And if we use a unit circle function values chart, I'm going to try to pull all this up together. All right, so if I find 135 degrees, which is here, the cosine is negative square root of 2 over 2 plus the secant of 45 degrees. So I'm going to find 45 degrees. I'm going to find the secant, and that is the square root of 2. And I'm going to add them together. In order to make this, I guess, a little bit simpler, I'm going to treat both as fractions. So I'm just going to put the square root of 2 over 1, right? In order for us to add fractions, we got to have a common denominator. So what's the least common denominator, bless you, between 2 and 1? Should be 2, right? So the least common denominator, that's actually the same thing as the least common multiple. So like if I were to write out all of the multiples of, let's say, 1, the multiples of 1 would be 1 times 1, which is 1. 1 times 2, which is 2. 1 times 3, which is 3. That'll keep on going forever. If I write all the multiples of 2, right, 2 times 1 is 2, 4, 6, 8, that keeps on going. I want the least common multiple, so the number that occurs first is 2. So the least common denominator between 1 and 2 is 2. Right. So I just mapped that out. 2 is my denominator. Now I have to make equivalent fractions. So what I mean by that is on this first fraction, negative square root of 2 over 2, the denominator was multiplied by 1. So we multiply the top by 1. So square root of 2 times 1 is still square root of 2. For that second fraction, I had to multiply 1 times 2 to get the denominator 2, right? I have to multiply my numerator by 2. 2 times the square root of 2 is 2 square root of 2. Okay, everything's still up. Why did it get big? All right. So now that I have a common denominator, I'm going to keep my common denominator, and I'm going to combine the numerators. Right. So now I'm going to simplify the numerator. What is negative square root of 2 plus 2 square root of 2? Well, keep in mind for your square roots, this is what this will look like. 2 square root of 2, that's just going to equal to 2 square roots of 2, right? So here I have the square root of 2 plus the square root of 2. All together, I have 2 square roots of 2. For negative square root of 2, that's just equal to negative square root of 2. Because I just got 1 negative square root of 2. So if I were to combine all of these things, what's going to happen? Right? I'm going to get some square roots to cancel out, right? So negative square root of 2 plus 2 square root of 2 is equal to the square root of 2 over 2. So once I simplify, the cosine of 135 plus the secant of 45, I should get positive square root of 2 over 2. Any questions about that one? Especially the square root stuff, because it's probably been a minute since you have played with radicals. Also, let's take a look at problem number 11. Let me copy that one over. No, that was problem 11. Okay, I'm sorry, problem number 10. Okay, that's what it is. All right, so we're going to do problem number 10 in the exact same manner. We're going to pull the values from the unit circle function of values, and then we're just going to add. All right, so the sine of 45 degrees, So I'm going to try to pull these up again. Okay, and I don't know what happened to this sheet. All right, so for problem number 10, the sine of 45 degrees, it looks like that is square root of 2 over 2. Plus the cosine of 135 degrees. So if I look at 135 degrees, the cosine is negative square root of 2 over 2. So if I were to combine these together, they're going to cancel out, right? Square root of 2 over 2 minus square root of 2 over 2 is 0. So for my problem number 10, okay, I'm going to get 0. And I believe the last one is number 17. All right, so here's problem number 17. All right, so here again, we're asked to evaluate. And in this example, we're asked to find the sine of pi over 4 times the sine of negative 5 pi over 6. All right, so as we search these values, the sine of pi over 4, that's going to be square root of 2 over 2. Okay, but what about negative 5 pi over 6? Well, first off, my unit circle function values doesn't give me anything negative. So what I want to do for negative 5 pi over 6, I'm going to change it to a degree just to find out where it is in the unit circle. So remember that pi is 180 degrees. So if I multiply negative 5 times 180 degrees, which is pi radians, and if I divide that by 6, I get negative 150 degrees. Right? So we converted it from radians to degree, but notice our angle is still negative. What could I do to negative 150 degrees to rewrite it as a positive angle? So remember we talked about coterminal angles where you can add or subtract 360. If I were to add 360, that gives me 210 degrees. So what that means is negative pi over 6 radians and 210 degrees, they're the same angle. The only difference is the amount of times they're being rotated. But they start at the same spot, they end at the same spot. So that means that, and let me just write some steps. Find negative 5 pi over 6 as a degree. I convert pi to 180 degrees, and I simplify. So that's negative 5 times 180 divided by 6, and that gave us negative 150. The next thing we had to do was find a positive coterminal angle. So we added 360 degrees, and we got 210 degrees. So here's what that means. The sine of negative 5 pi over 6, and those little squiggly equal sign, that means it's equivalent to the sine of 210 degrees. So that means I can find the sine of 210 degrees using the unit circle value chart. And I believe I should get negative 1/2. So this should equal to negative 1/2. And this is times. Because notice that this is a product, sine of pi over 4 times. So I'm not adding or subtracting. I'm actually going to multiply. So in order to multiply fractions, we multiply our numerators, multiply our denominators. So a positive times a negative is a negative. Square root of 2 times 1 is square root of 2. 2 times 2 is 4. So negative square root of 2 over 4 should be our value. All right. Any questions about section 1.4? So you can basically pull all of the answers, except for those 3 we just went through. You can pull all of those trig function values from that unit circle function values. All right, today I want to get into the next section. I just want to kind of introduce that. And this is the right triangle trigonometry section. And in right triangle trig, whenever you solve a triangle, that simply means to find all of the side lengths and all of the angle measures. So let's take a look at how that's done. And before I do that, in the calculator, I want to talk about, these are called arc functions. You have a sine, a cosine, and a tangent function, right? Well, I guess I should do this. You also have, this is called an arc sine or inverse sine, which is right above sine. This arc sine, that's not the cosecant. Above cosine, you have cosine raised to the negative first power. That is arc cosine or inverse of cosine. And then above tangent, you have tangent to the negative first power. That is arc tangent or inverse of tangent. The sine, cosine, and tangent buttons are used to find side lengths. So when you're asked to find like side A and side B or side C, you're going to use sine, cosine, or tangent. Other times you're going to be asked to find an angle measure, like angle A, angle B, angle C. To find angle measures, you use these arc functions. Okay. So now with that being said, I just want to talk about a right triangle for a minute. just some facts about a right triangle. All right, so notice here is a right triangle. The reason I know it's a right triangle is because of this box. And normally this box will be red. And what that means is that is a right angle. So if you don't see a box, I wouldn't necessarily assume that it's a right angle, unless they tell you it's a right angle or unless you see the box. There is something called standard labeling of a triangle. And this is standard labeling. All of the angle measures have capital letters. Right, so I'm going to call this angle A. I'm going to call this angle B, and I'm going to call this angle C. And normally when they sketch out the right triangles, they use C as the right angle letter. So angles have capital letters, and in order to find angles, we're going to use these arc functions. Side lengths have lowercase letters. So if this is angle A, the side that's opposite angle A, that is side length A. Because in some of these problems, they'll give you a triangle, and in another problem, they're just going to tell you angle A is equal to this, angle B is equal to this, or side B is equal to this. This is angle B. The side that's opposite angle B is side B. And that's a lowercase letter. And now I have angle C. The side opposite angle C is side length C. So angle have capital letters, side length have lowercase letters. Here are some facts about a right triangle. The hypotenuse, and the hypotenuse is the side opposite the right angle. The hypotenuse is always the longest side in any right triangle. Okay. The hypotenuse is always the longest. The sum of the measures of the angles of any triangle, doesn't necessarily have to be a right triangle, but any triangle is 180 degrees. So what that means is if you were to add angle A plus angle B plus angle C, they should always give you 180 degrees. All right. So when you are asked to set up a trig function, that should be trig function. You want to label your angles and sides according to Chief Sakatoa. So whenever you set up a trig function, we're going to use this thing called chief secretore. So what this alludes to is that the sine, and like I mentioned earlier, we're going to deal with two types of triangles. One type of triangle is in that rectangular coordinate system, and that's where you use X, Y, and R. And then you're going to be looking at triangles that are not in a coordinate system. They're like hanging out in space. For those, we're going to use this chief secretore. So what this alludes to is that the sine is the opposite over the hypotenuse. The cosine is the adjacent side over the hypotenuse. And the tangent is the opposite side over the adjacent side. All right, so we're going to take a look at setting up some trig functions to find angle measures and side lengths. So in section 1.5, let's take a look at number 6. I'm going to copy that over. All right, so let's take a look at this problem number 6. So it says find the lengths of sides of angle measures of the right triangle. It says do not round intermediate steps, but round your answer to 4 decimal places. There's something in this class called rounding error. So let me just explain rounding error. Rounding error occurs when you use a rounded number in a calculation and you're going to round again. That could bring some rounding error. So I don't know if some of you may encounter this or not. You say, hey, why is this like 1/10 of a point off? Instead of it being like 3.4, I'm getting 3.5 or 3.6. That may be because of rounding error. In this course, and in math in general, you should only round your final answer. So that's what it means by don't round your intermediate steps. So in this course, we're only rounding the final answer. All right, so let's take a look. All right, so we have a right triangle. We have triangle ABC. Notice they may orientate it a different way. The capital letters are angle measures, lowercase or side lengths. They're always using standard labeling. So they give us some dimensions. They tell us that B is equal to 8. So I'm just going to jot that in. And angle A is 10 degrees. We're asked to find side A, side C, and angle B. All right, so let's take a look at finding these measurements. The first thing I'm going to do is label all the sides of the triangle. So when I say label all sides, I want to find the hypotenuse, I want to find the opposite, I want to find the adjacent. Because all of those things are in that chief secretore. The sine is the opposite side over the hypotenuse. And we already talked about the hypotenuse, that's opposite the right angle, and that's always the longest side in any right triangle. The cosine is the adjacent side over the hypotenuse. and the tangent is the opposite side over the adjacent. So I want to label opposites, the hypotenuse, and then any adjacents. So when I start to label my triangle, I always label the hypotenuse first, right? So my hypotenuse is going to be side C. So that's my hypotenuse. So that's the first thing we did, was find the hypotenuse. The next thing I want to do is choose, and this is the important part, choose a reference angle. Now we talked about a reference angle. A reference angle is any angle between 0 and 90 degrees, right? It's in the first quadrant. The reference angle that you choose, one person may choose one reference angle, another person may choose another reference angle. But if you label your sides according to your reference angle, you can't go wrong. So if you ever heard the expression, there's more than one way to skin a cat, somebody might set it up this way, somebody might set it up this way, but the final answer would be exactly the same. The reference angle that I'm going to choose is, you never choose your hypotenuse as a reference angle. So let me just write that out. Choose a reference angle, but never the hypotenuse. And never that 90-degree angle. Right? I'm going to choose A as my reference angle. Some people may choose B as their reference angle. That's totally up to you. But I'm going to choose A as my reference angle. So as I'm choosing A as my reference angle, I have to pull out the opposite side and the hypotenuse. The opposite to angle A is going to be side length A. So where I have side A, I'm going to put opposite to angle A. That's my opposite side. B is going to be my adjacent side. So B is adjacent to A. Now, two things are adjacent if they share a common side. For example, this is room 1111. I don't know what that room is next. I think that's 1112. These rooms are adjacent because they share this common side, this common wall. Angle A and side B are adjacent because they share this common side. So now I have everything labeled out, my opposite, my hypotenuse, and my adjacent. So now we're going to set up a trig function to find side A. Okay. So the second thing we're going to do is find side A. Right. So I'm going to have to set up a trig function. So in these trig functions, there's three things you got to know, right? So like if I'm using the sine is the opposite of a hypotenuse, I got to know at least two of these things, and I can solve for the unknown. So if I want to find side A is the opposite, so I have to use the opposite. I'm going to use the adjacent because I know the value of B. And then I'm going to use this angle measure of 10 degrees. So if I'm setting up a trig function, I'm looking for a trig function that has an opposite and the adjacent. So if I go back to the Chief Sokotoa, the tangent function is the opposite side over the adjacent side. So that's the trig function I want to use. So now how will I write that out? Well, I'm going to write it out like this. The tangent of A, which is 10 degrees, that's equal to the opposite, which is side A, over the adjacent, which is 8. And that's my trig function. The tangent of 10 degrees, so that's my tangent of 10 degrees, that's equal to the opposite, which I don't know, so that's A, over my adjacent, which is 8. So now I'm going to solve this trig function for A. So in order to solve it for A, what should I do? Well, I can multiply both sides by 8. So if I multiply the left-hand side by 8, I have 8 times the tangent of 10 degrees. If I multiply the right-hand side by 8, my 8's are going to cancel. So I have 8 times the tangent of 10 degrees. That should give me side A. So we're going to use the calculator. Now here you have to be careful when using a calculator, because if I go into mode, there is a radian mode and a degree mode. Since I have a degree measure, I just want to make sure that my calculator is in degree mode. Anytime you deal with a trig function, be mindful of your mode. So I changed mine to degree. So now I'm going to evaluate this. I'm going to multiply 8 times the tangent of 10 degrees. So remember, I'm in degrees. And I should get 1 point, it says round to 4 decimal places, 1.4106. So that's side A. Any questions on how I set up that trig function? Now let's find side C. All right, so A is 1.4106. Okay. Now I want to find side C. Now I could set up another trig function, but normally when you're going through these problems, you should only set up one trig function. How could I find side C without using a trig function? Well, if I have a right triangle, and if I have 2 sides for that triangle, I can find the third side by using the Pythagorean theorem. So I'm going to do it both ways. I'm going to set up another trig function. I'm going to also use the Pythagorean theorem. So this will be the Pythagorean theorem, and this is what you should do. You only want to set up one trig function. And then once you set up the first trig function, you should be able to find everything else by using the Pythagorean theorem. And then also using the fact that when you add up these angles inside of your triangle, they should add up to 180 degrees. All right, so I'm going to use the Pythagorean theorem. So C squared is equal to A squared plus B squared. C is equal to the square root of a squared plus b squared. C is equal to, and I'm pausing because right here it says do not round intermediate steps. So that means that I should not put 1.4106 in squares because I'm using a rounded value in another calculation, so I may get rounding error. Right. So this is what I'm going to do. I'm going to put 1.4106. I'm going to put like dot, 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 and that's squared plus b, which is just 8 squared, right? So now this is what I'm going to do with my calculator. I'm going to take this 1.4106. Now, even though this looks like it may appear to stop, I believe this thing just keeps on going. I'm going to hit STO for store. I'm going to store that for X. So that means if I hit X, it's going to substitute X for that true number. In my calculator, I'm going to put in the square root of X squared, so that X is holding that true value for that 8 times the tangent of 10. Okay, storing all of those digits, plus 8 squared, and we should get 8.1234. Any questions on where 8.1234 comes in? I used Pythagorean theorem. I didn't use any rounded values. I used a calculator and I put it in. Now you could set up a trig function. I'll just show how that works. I would not advise you to set up 2 trig functions, but you could. So that was a Pythagorean theorem. Let's say or trig function. So if I go back and set up another trig function, notice that I want to find side C, which is the hypotenuse. I'm staying away from this rounded stuff, so I'm going to use the adjacent side because they gave us that it was 8, and I'm going to use my 10-degree angle. What trig function has an adjacent and a hypotenuse? We think about the chief Sokotoa, that would be a cosine function. The cosine of some angle is equal to the adjacent divided by the hypotenuse. Well, the adjacent times the hypotenuse. So let me write that out. So that would be the cosine of 10 degrees so I'm using this function. The cosine is the adjacent over the hypotenuse. That's equal to the adjacent, which is 8, divided by the hypotenuse, which is C. So this is what my trig function looks like to find C. How would I solve for C? Well, much like we did in that first trig function setup, first thing I want to do is get rid of the fraction. So I'm going to multiply both sides by C. So if I multiply the left-hand side by C, I get C times the cosine of 10 degrees. And if I multiply C by the right-hand side, the C's cancel. And now in order to solve for C, I can divide both sides by the cosine of 8, by the cosine of 10. And I have C is equal to 8 divided by the cosine of 10. So in my calculator, now my calculator, you're going to see me do this a lot. It's like I'll just go in and rate in, because this calculator has a mind of its own. Like it'll like flip-flop without me doing anything. But on your handheld calculator, you have to manually move this over from radian to degree. All right, so I just have to make sure I'm in degree mode. So 8 divided by the cosine of 10 degrees. And we get that 8.1234. We get that same exact value. But I would not want you to do it that way. I would just want you to use the Pythagorean theorem. But it's possible if you just choose yourself another trig function. So any questions about finding C? All right, now we're asked to find angle B. So in order to find angle B, I'm going to use the sum rule. And the sum rule just states that all of the angles inside of the triangle have to add up to give you 180. So B, that's going to equal to 180 degrees minus 90 degrees plus 10 degrees. So here's what I'm doing. I'm taking 180 degrees, which is what all our angles should add up to give us, minus 90 and 10 degrees, and those are just the angles I already know, right? So angle C is 90 degrees, angle A is 10 degrees. So if I add 90 and 10, we get what? 100 degrees, and 180 degrees minus 100 degrees is 80 degrees.